Hello, I'm here today to review why is measurement so important in science. So throughout the lesson today, you're going to hear about us talk about the metric system. You're going to hear us talk a little bit about the English system of measurement because many of you guys might be more familiar with that system. But in science class, we're really going to be focused on the metric system. We're also going to discuss in this video the difference between accuracy and precision. And there's also a couple videos that are attached in this Google slideshow. So please feel free to watch them if you were out or on quarantine or missed today's lesson. So do you think measuring is important in science? And obviously it's very, very important. Everything that we do in science, in our science labs, in our science activity, a lot of times it deals with math or data, collecting data, analyzing our data. So it's important that we know how to measure and then how, what units we're going to be using and what tools we're going to be using in science class. So you may or may not have heard this before, but you want to be both accurate and precise in science, not just in our classroom, but in the real world. Accuracy in science is very important. So the definition of precision is how close a group of measurements are to each other. That's kind of the key point there. How close a group of measurements are to each other. And we're going to see, you can kind of see on that video that I would encourage you to watch. If you're shooting bow and arrows or darts, or you're on a target, precision is really referring to all of those darts or those arrows being in the same location, but not necessarily being at the bullseye. Okay. Accuracy is how close a measurement is to the true or the accepted values. So that would be accuracy would be getting a bullseye, right? So we want to both have precision and accuracy in science. In some of the labs that we're going to do, you're going to have to measure certain objects. And with those objects, we want you to both be accurate and precise. Accurate and precise.
Thanks for...
So if you look here, this is actually the Pear Deck that we're going to do in class, but you can see that there's a red star and a blue star. Which one of the following targets is accurate and precise? So that's going to be obviously this one right here, accurate and precise. The next one, blue star, which one of the following targets is not accurate and not precise? And that's going to be basically all over the place, which would be this one right here, the fourth option. The green star is accurate and not precise. So accurate and not precise. So if you can see here, all the arrows are all over the place, but they're very, very close to the bullseye. And then purple star is not accurate, but it is precise. So you can see all those arrows end up almost exactly at the same point, but they're not on that bullseye. So when you're talking about accuracy and precision, like I said, we strive for both in science class, depending on what kind of data and what lab we're going to be doing, but both are very important. And this is just a kind of a review of those targets that you saw on the previous slides. So now let's talk about the metric system. The metric system is the system of measurement that we will be using in science class. And this should not be, this shouldn't sound crazy to you, because in 7th grade, hopefully you use the metric system. So the units of the metric system you should be familiar with, as well as the science tools that you also use. So this is another video that I'm going to ask that you watch just to kind of reinforce the difference between English and metric. So if you look at this slide, it's comparing the English or the American system of measurement with the metric system. So what you see on your left, which is right here, you probably are very familiar with these units because you live here in America, and this is the system of measurement that unfortunately or fortunately we use. You can see here English is inches, feet, pounds, ounces, gallons, and Fahrenheit. Whereas in science class, we're going to be using centimeters, meters, kilograms, grams, liters, and degrees Celsius. So as you can see on the map, there's very few places that use, there's actually 3 countries in total that use the English system of measurement, and the United States being one of them. And that video that you watched just before will tell you why. And then the rest of the world, which is actually a pretty cool thing, the rest of the world has adopted the metric system over hundreds of years. I wouldn't say hundreds, but over 100 years or so, that we can kind of all agree with that. And the main reason why you want to agree and you want to all talk metric is because when scientists share their studies, it's important that they're using those same data points and the same units, so that it's easier to understand. So again, Circle the column of words that we should be using in science class. So if you look at what you're familiar with, the correct answer is right here, the metric system unit. So now we're going to talk about each of the different things that we could measure. Temperature is our first one. So if you look here, we use a thermometer to record temperature. And in science class, we're going to be using degrees Celsius. So you're going to have a thermometer, you're going to be able to read it, and we care about degrees Celsius. You might be more familiar in your own life with Fahrenheit, knowing that it's, for example, 70 degrees out or 75 degrees out. You might not know what that means in Celsius, but when we do lab activities, you will be using the metric system, which is degrees Celsius. So as it says, from our lab, circle the water of our ice water bath. So what you should know, or what you should take note at, is it's right here, right? Water freezes. So if you recall, it was right around 0, our ice water bath. And then if you look over here, if you're looking at the Fahrenheit scale, which we don't use in science, you might be familiar with that 32, especially when we have snow days. You're always looking for that 32 value to see if, in fact, we will have snow, or if it's going to be a slush or sleet or hail. So that's the magic number in the Fahrenheit scale. But it makes it a little easier. It's 100 degrees Celsius for water boiling, 37 degrees Celsius for human body temperature, and 0 degrees Celsius when water freezes. So on this activity, you're going to identify for me what those values are. It says, please write above each thermometer what those values are. Next is recording. We did temperature. Now we're going to be down to mass. So we use the science tool of a triple beam balance or a digital scale to actually figure out the value of, whatever the mass of something might be. So the amount of matter that it has. So the units of measurement that we're really going to be focused on, believe it or not, is actually grams. But there's also kilograms and milligrams, which are also common units in science class. So if you look at this triple beam balance, you add up all of the riders. Once that is at a 0 point on the balance, which if you did the lab, then you probably already know what that looks like. So this one is 167 grams. Next is time. And also, as a side note, the digital scale is a lot easier. You don't have to add anything up. It will just tell you your unit value. Next is time. We measure a lot of time in science class, but we're going to be measuring them using a stopwatch, okay? Or, we have stopwatches from our lab this week. You guys might use a second hand on the clock or, a stopwatch timer on your phone. But you're going to be using minutes and seconds. Seconds is probably a more accurate value. So you say 60 seconds opposed to minutes, but that is a measurement of time. Volume. Volume can be recorded or measured a variety of different ways. If you look here on this slide, the most accurate, we just talked about accuracy before, the most accurate way to record liquid volume is going to be using a graduated cylinder. And that's basically the long, thin one that has graduations on it, which is basically like number marking, so you know what your values may be. They can be recorded in liters and milliliters. More commonly in our class, we're going to be recording in milliliters. You also have to be mindful of reading at the meniscus, it's called. You're going to get eye level, so you're going to squat down at your lab benches, and you're going to see where that little kind of curvature ends up, and that's going to be your accurate value. So if you look at your scale right here, you see 20, you see 30, halfway between 20 and 30 is 25. So this unit value that you see is 24 milliliters, 24 milliliters. And then the last point of measurement that is important is distance and distance or length. And depending how long that distance or length or what the object may be, you can either do it in meters, which is a meter stick, which I have shown you in class, centimeters, which is more common, and millimeters. So they're going to be your base units, meter being your base units, but a lot of times we need smaller units, so we do centimeters or millimeters as your unit value. So you can see here how long is this pencil. So you look there and you're like, okay, 1, 2, 3, 4. So it's 4 centimeters. Okay, it always should be zeroed. You always should start out at the 0 line. So that's how I know it's 4 centimeters. You just look at the difference between there. Again, just to reiterate, this is if you're trying to find length and width and height or a volume of a solid, that's your formula, length times width times height. Otherwise, it'd be just length times width. So these are your scenarios, which I really like. It's what science tool do you use? So it's a beautiful fall Saturday. Some of your classmates decide it's the perfect day to go out on their dirt bikes. You want to join, but are unsure of what to wear due to temperature. What science tool can you use to find this out, and so you can get dressed properly and get going on your biking day? What tool would you use? So the correct answer is a thermometer. More specifically, you would use a thermometer in degrees Celsius if you were in science lab. Otherwise, you would check the weather and it would probably be in degrees Fahrenheit. Next, you decide to sign up for a local art contest. You are assigned to a small sculpture that uses clay. You are told you must not use more than 10 grams of clay for this mini project. How would you make sure that you stay within these guidelines? What science tool could you use and how could you use it? So if you're talking about grams is a measurement of mass. So if you had a digital scale or if you had a triple beam balance, those would probably be the best tools to figure out to measure out 10 grams, and then you can use it for that project. Continuing. It's a Friday night. You had a long week at school and decide you just want to take it easy this weekend. Ordering pizza and playing some video games sounds like a perfect plan. You go to connect your gain system and realize one of your cords is not working. You need to go to Amazon and order a new one as soon as possible. On Amazon, you see there are many different cord lengths options, all in centimeters. How would you measure to find out which cord you need? And what tool would you use and why? So if you're looking at length or you're looking at distance, you're going to need to figure out that you would use either a meter stick or a metric ruler, and you would measure the distance between the TV and your gaming console to see kind of what would work best. So that would be for that option. And then you just went to Sephora and picked up some new liquid mascara. This makeup is expensive, so you're curious to know if you're getting the correct amount in the bottle, which is a volume. You decide you want to measure it for yourself. How could you measure liquid like this if we wanted to know how many milliliters there are in the mascara? Which tool would you use? So the most accurate way to record liquid volume would be using a graduated cylinder. Now, it's probably going to be difficult to get that liquid mascara out, but that's how I would suggest the science tool in milliliters would be the best way to figure out that value. And then last but not least, you really want to try out a new TikTok dance. You have it planned out, but want the timing to be just right before you record it yourself. What tool could you use to get an accurate recording of time in minutes and seconds? And this one should probably be the easiest one of them all. The correct answer is a stopwatch. So with that being said, that is the lesson for today that you missed. If you need to rewatch this over because you need clarity, or if you want to reach out to your teachers about anything else, please feel free. And thank you for watching.